Hello students! Today we're going to look at solving quadratic equations by factoring. And this is a really exciting moment for us because we've spent almost 2 weeks learning different factoring methods, and now we are finally going to be able to apply those to solve some equations. It's not going to be about learning how to factor anymore. It's going to be using these factoring skills to actually solve equations. So let's jump in with a definition. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0. Now, it might be that we have an equation where we don't have all the terms on the same side. Maybe the constant term is on the other side and we've got to move it, but it still counts as a quadratic equation. So a few examples of quadratic equations could be x squared minus x minus 6 equals 0, or x squared minus 3x equals 10, or x squared minus 8x minus plus 16, equals 0. Each of these is a quadratic equation, and we can solve these using something called the zero factor property. And this is something that you already know. You might not be aware of it, but let's talk about it. The zero factor property says the following: if a times b equals 0, then something must be true. Now, what has to be true if we multiply two numbers together and end up with 0 as a result? At least one of them had to be 0. So in this case, if ab equals 0, then a equals 0 or b equals 0. This is the zero factor property. If we multiply two things together and end up with 0, one of those things had to be 0. And we're going to use this when we're solving quadratic equations. Let's take a look at the first example. Let's solve x squared minus x minus 6 equals 0. Now, we can't solve this using the methods that we had learned previously. We can't just try to get x alone because there's two terms with x's, and one of them is an x squared and the other isn't. So they're not like terms. We can't be combining them. And there's no way to just get x alone on one side and end up with x equals a number. However, we have learned how to factor polynomials, and factoring this polynomial is going to help us get the answer. Let's factor it first, and then I'll show you why this is helpful. Now, there's 3 terms here. There's no GCF to pull out, so we're going to either have to use unfoiling or the AC method. Because there's no leading coefficient, we're going to end up using unfoiling. We're looking for two numbers that have a product of -6 and a sum of what? Can you see it? -1 is the coefficient on the x. There's an invisible 1 there. So we need two numbers with a product of -6 and a sum of -1. Those numbers are -3 and +2, which means when we factor this, we get x minus 3 times x plus 2, and we know that that's equal to 0. Now, what we've done here by factoring this polynomial is we've written it as a product. And remember what the zero factor property says. It says if we have a product of two things that equals 0, then one of those factors is equal to 0 or the other one is equal to 0. So in this case, because we have a product of two factors equaling 0, the first one's x minus 3, the second one's x plus 2, What that means is either the first factor equals 0, x minus 3 equals 0, or the second factor, x plus 2 equals 0. I really love highlighting things. I hope it helps you to see where certain things are coming from. When we have a product that's equal to 0, either the first factor has to equal 0 or the second factor has to equal 0. By factoring this polynomial and using the zero factor property, we've split this into two simpler equations, and we can solve each of these. In the first equation, to get x alone, we add 3 to both sides. Oops, haven't switched back to the main pen. When we do that, we get x equals 3. For the other one, we subtract 2 on both sides to get x alone. That gives us x equals 2. And so our final answer is going to be x equals 3 or x equals 2. There are actually two solutions here. And the reason we're able to get two solutions is because there were two factors. And the reason we were able to get two factors is because we had this x squared here. So in general, when we have a quadratic equation with an x squared term, we are usually going to end up with two solutions. There's an exception, which we'll see in just a little bit, but we usually expect there to be two solutions. Let's move on to the next one. X squared minus 3x equals 10. Let's solve x squared minus 3x equals 10. Now, we're not allowed to just start by factoring the x squared minus 3x. The reason is, to use the zero factor property, we need one side to be equal to 0. So before we do any factoring, we've got to get all the terms on one side, let the other side be equal to 0, and then we can do our factoring. How do we move this 10 to the other side? We can subtract 10 from both sides of the equation. When we do that, we get x squared minus 3x minus 10 equals 0. And now we're in a position to factor because the other side's equal to 0, and once we've factored, we can use the zero factor property. Now, when we factor this, we're going to unfoil because it's a trinomial, and we have a leading coefficient of 1. So we're looking for two numbers that have a product of -10 and a sum of -3. Those numbers end up being -5 and 2. So when we factor this, we get x minus 5 times x plus 2 equals 0. And now the zero factor property tells us that since we have a product that equals 0, we can set each factor equal to 0. When we do that, we get x minus 5 equals 0, or x plus 2 equals 0. And if we solve each of those for x, for the first one we've got to add 5 to both sides. That gives us x equals 5. For the second one, we've got to subtract 2 from both sides. That gives us x equals -2. And so we end up with our final answer, x equals 5, or x equals -2. If you want to check any of these, you can substitute these values into the original equations. I will let you do that on your own time. When you check these, you should get that both of the solutions work. All right, we're going to end up doing one more of these together now, and then I'm going to encourage you to look at all the example problems. Let's look at x squared minus 8x plus 16 equals 0. Again, we're going to factor using the unfoiling method. And I have to say, not all of the problems we're going to do are going to be unfoiling. I wanted to do 3 unfoiling problems in a row just so you can get a little bit of consistency. But when you look at the other examples, you're going to have GCFs, you're going to have grouping, you're going to have the AC method. It's going to be all of the different methods that we end up using. But for now, we're unfoiling. We're looking for two numbers with a product of 16 and a sum of -8. And those numbers are -4 and -4. So when we factor this, it becomes x minus 4 times x minus 4 equals 0. And then we set each factor equal to 0. So we've got x minus 4 equals 0 or x minus 4 equals 0. Because these are two copies of the same equation, they're going to give us two copies of the same solution, so we only really need to solve one of them. Let's solve the first one. We can add 4 to both sides to get x equals 4. And in this case, we have only one solution because both of the factors were the same, so both of those would give us x equals 4. And we don't need to write x equals 4 or x equals 4. When there's just one solution, we can write it out. X equals 4. That's our final answer. Make sure you take a look at the other videos. Those will give you examples that involve pulling out GCFs, using grouping, using the AC method to give you a better idea of all the different ways we can solve quadratic equations by factoring.